Today we are going to be talking about applications of matrices. By the end of this video, you should be able to find the area of a triangle given three ordered pairs. You should be able to find the equation of a parabola through 3 points, and you should be able to encode and decode secret messages. First, one way to find an area of a triangle is using this formula. You have plus or minus 1/2 times the determinant of this matrix. The matrix has the x and y coordinates of the points, and then the third column is just a bunch of ones. So if you have a triangle on a graph, you can use the coordinates, find the determinant of the matrix, and use that to find the area of the triangle. So let's find the area of the triangle with vertices 5, 6, 12, -3, and 1, 2. So we have the area is plus or minus 1/2 the determinant of this matrix. 5, 6, 1, 12, -3, 1, 1, 2, 1. When we find the determinant, we can use any row or column. I'm going to go ahead and use the third column because it has the smallest numbers. Remember that we have to assign positive and negative values. So when I find the determinant of this matrix, I'm going to have plus or minus 1/2 1 times, cross out the row and column, the determinant of the matrix, 12, -3, 1, 2, minus 1 times the determinant of the matrix, 5, 6, 1, 2, plus 1 times the determinant of the matrix, 5, 6, 12, -3. To find the determinant of a 2 by 2 matrix, remember you multiply the principal diagonal and subtract the product of the other diagonal. So we have 24 minus -3 minus 10 minus 6 plus -15 minus 72. If we go ahead and simplify, we have plus or minus 1/2 of 27 minus 4 minus 87. So plus or minus 1/2 of -64. Because area is always positive, that's why we have the plus or minus. We end up with area equals 32, and we were not given units, so we'll just say square units. What if we used this formula and found that the area of the triangle was 0? Well, that means that the points are collinear, meaning that they are all in a straight line. They do not form a triangle. So if we want to prove that these points are collinear, we need to prove that the area formed by the triangle is 0. So we have area equals plus or minus 1/2 the determinant of 1, 2, 1, 7, 6, 1, 4, 4, 1. Again, I'm going to choose to use the third column. Remember when we assign our plus and minuses. So I get that the area is plus or minus 1/2 of 1 times the determinant 7644 minus 1 times the determinant of 1244 plus 1 times the determinant of 1276. We need to find the determinant of each of these 2 by 2 matrices. So we get 28 minus 24 minus 4 minus 8 plus 6 minus 14. So when we do our math, we get 4 minus negative 4 plus negative 8, and we end up with 0. This shows that these 3 points are in fact collinear. Next, we want to find the equation of a parabola that goes through the points -1, 5, 2, -1, and 3, 13. Well, the equation of a parabola is y equals ax squared plus bx plus c. I'm going to take each of these points, plug in the x and y values, and end up with a system of equations where I have 3 equations and I'm solving for a, b, and c. So if I plug in the x and y value for each of these points, I get 5 equals a times -1 squared plus b times -1 plus c. -1 equals a times 2 squared plus b times 2 plus c. And 13 equals a times 3 squared plus b times 3 plus c. So when I go ahead and simplify these, I get 5 equals a minus b plus c. -1 equals 4a plus 2b plus c. And 13 equals 9a plus 3b plus c. As we saw in our last tutorial, the best way to solve this system is by using the augmented matrix. So if I write out our augmented matrix, I'm going to have 1, -1, 1, 5, 4, 2, 1, -1, and 9, 3, 1, 13. Remember that my goal is to have the identity matrix on the left side of the line and numbers on the right side of the line. The first thing I need is to have a 1 in the first row, first column, which I do. Now my next goal is to get zeros in the rest of column 1. So if I say row 2 is equal to -4 times row 1 plus row 2, and row 3 is equal to -9 times row 1 plus row 3, that should give me zeros in the rest of column 1. So row 1 does not change. -4 times row 1 plus row 2 gives me -4 plus 4 is 0, 4 plus 2 is 6, -4 plus 1 is -3, and -20 plus -1 is -21. -9 times row 1 plus row 3 gives me -9 plus 9 is 0, 9 plus 3 is 12, -9 plus 1 is -8, and -45 plus 13 is -32. The next thing I need to do is make second row, second column a 1. So I'm going to do that by multiplying row 2 by 1/6. So if I multiply row 2 by 1/6, I'm going to get 0, 1, negative 1/2, and negative 7/2. Row 1 and row 3 do not change. The next thing I need is for the third row, second column, to be a 0. So I'm going to say that row 3 is negative 12 times row 2 plus row 3. So if I do negative 12 times row 2 plus row 3, I get 0 plus 0 is 0. Negative 12 plus 12 is 0. 6 plus negative 8 is negative 2. And 42 plus negative 32 is 10. The next thing I need is for the third row, third column, to be a 1. So I need to multiply the third row by negative 1/2. So the first two rows stay the same. If I multiply the third row by negative 1/2, I have 0, 0, 1, negative 5. Next, I need the rest of the third column to be zeros. So the second row is going to be 1/2 times the third row plus the second row, and the first row is going to be negative 1 times the third row plus the first row. So the third row stays the same. If I multiply the third row by 1/2 and add that to the second row, I get 0 plus 0 is 0, 0 plus 1 is 1, 1/2 plus negative 1/2 is 0, and negative 5/2 plus negative 7/2 is negative 6. If I multiply the third row by negative 1 and add it to the first row, I get 0 plus 1 is 1, 0 plus negative 1 is negative 1, negative 1 plus 1 is 0, and 5 plus 5 is 10. The last thing I need to do is make the first row, second column, a 0. So to do that, I'm going to say that the first row is the second row plus the first row. So the second and third row stay the same. First row, I'm going to add the second and the first row together. So 0 plus 1 is 1, 1 plus negative 1 is 0, 0 plus 0 is 0, and negative 6 plus 10 is 4. Now my matrix is in reduced row echelon form. So my solution is that A is 4, B is negative 6, and C is negative 5. So that gives me the quadratic y equals 4x squared minus 6x plus 5. And if you graph that in your calculator or using Desmos, you can verify that our 3 points are in fact on that curve. Let's look at one last thing. Cryptography is the study of codes and code breaking. One way you can encode something is using matrices. we picked our arbitrary encoder matrix. We have a 2 by 2 matrix, 4, -5, 2, 0. The decoder matrix would be the inverse of our encoder matrix. So if we figure out the inverse of this matrix, we know we have 1 over the determinant, which is 0 minus -10. Then we have to rearrange our matrix. We switch A and D and negate B and C. So if we go ahead and multiply the scalar, we end up with our decoder matrix being 0, 1/2, -1/5, and 2/5. So if I had the encoder matrix and I was going to encode a message, send it to you, you would have to have the decoder matrix to be able to decode the secret message. So we want to encode the message, "Go Patriots." So we are going to start with a basic substitution cipher. A is 1, B is 2, C is 3. You continue. Y is 25, Z is 26. And we're going to go ahead and let a space be 0. So I'm going to take this message and make it into a matrix with 2 columns. So first, G is the 7th letter of the alphabet. O is the 15th. Then we have a space, so that's 0. P is the 16th letter of the alphabet. A is the 1st. T is the 20th. R is the 18th. I is the 9th. O is the 15th. T is the 20th. And S is the 19th. Since I need one more letter, I'm going to go ahead and put a space again. Now, to encode this message, you need to take this matrix and multiply it by our encoder matrix. Remember that for matrix multiplication, you need to multiply the first row times the first column. So we're going to multiply these by these. So we do 7 times 4 is 28, plus 15 times 2, which is 30. And we end up with 58. And we're going to go ahead and do that for the rest of the matrix. So when we multiply our matrices together, this is what we get. So that would be the secret code that I would send to you. Now, if you want to decode this message, you would take this matrix and multiply by the decoder matrix. So let's go ahead and rewrite our secret message. So we have our secret message that you received, and you want to multiply this by the decoder matrix, which we said was 0, 1/2, -1/5, and 2/5. So again, if you multiply these together, multiplying the first row times the first column, so 58 times 0 plus -35 times -1/5, you get 0, plus 7, which gives you 7. And if you continue multiplying, you get this matrix. You would then go back to the letter assignments and see which letter corresponds to which number. And you would get GO space PATRIOTS space. So you get the message, Go Patriots.